Did you know you can solve every SAT math problem with Desmos? In this video, I'm going to teach you how Desmos can help you solve almost every single type of SAT math problem on the test, ranging from inequalities, systems of equations, regressions, circle questions, mean, median, and more. Timestamps are below. You can find it just by typing in desmos.com, and it's going to be the first one that pops up, Desmos Beautiful Free Math, and you're going to want to go ahead and just open Graphing Calculator. So Desmos is just an online graphing calculator that you are able to use on the SAT exam. Why it's fantastic is that it can graph equations really quickly, and it's very easy to find points on an equation or graph like the x-intercepts, the y-intercept, all the stuff I'm going to cover in this video. So here's how to use Desmos fast on the SAT. You need to know where all the buttons are. So down here in the bottom left corner is the keypad. If you click that, it opens up and it shows you the same buttons that a normal graphing calculator would have. What's interesting is you need to know what's under the functions tab. So when you click that, it has your sine, cosine, tangent, and all these other inverse trig that you probably won't have to use. And then you have your mean, median, and minimum, maximum stuff. And then last and most importantly, when anything is to the nth root, you're going to want to click this button. And so here are all of Desmos's shortcuts. Let me show you how to use them. Shift 8 for multiplication, slash for the division, square root, where you type in SQRT. Mean, you have to literally type in mean using your keyboard and then put parentheses around all the units in your data. That's what those apostrophes mean. It means you have to type it in. Same with if I wanted to find the median of this data set. And then distance is an odd one because when you type in distance, you're going to want to put parentheses, but then you're going to want to put each point in parentheses as well. So you do another parentheses, putting your X value, your Y value, closing it, comma for the next set, X value, Y value, and then it'll tell you the distance between those 2 points. Same for the midpoint. And then SOHCAHTOA is not on that list, but it's cosine and so on. The easiest problems to solve with Desmos are these single variable equations. So if you take a look at the practice example I am showing, just go ahead and type it into this bar and just type in X normally. Don't do anything fancy. You would just do 16X plus 24 equals 24X. And as you can see that it shows a line going up and down. This line signifies the solution to the problem. It solved for X for us. For all single variable equations where you just have one X, you can just type it into Desmos, and where it crosses the X axis will be the correct answer. How Desmos can solve linear equations on the SAT. Desmos is fantastic for linear graphs and equations because it can show you where the y-intercepts, the x-intercepts are. Let's imagine I just did a simple y equals mx plus b. We can see that the solution to this equation would be the x-intercept, and that crosses over at -1, 0. And then the y-intercept would be 0, 3. Let's see what it looks like with a practice question. So this question just tells me, the slope is 5, so we know it's 5x, and then the y-intercept is going to be -35. We can very quickly find the solution, and it's 7. If you look at this next question, for some reason, instead of putting x, they put t. Don't be freaked out. It's not a constant. They just replaced x with t. This is them being like, hey, I want you to solve it by hand, but we're smart. We're just going to replace t with x so we can graph it, because Desmos can only graph x and y values because it's a x and y plane. It makes sense. So let's go ahead and type it in with x for t. And we can see that we have a vertical line going through the x-axis telling us our solution, and that -22 would be what x is. So in this case, t equals -22 as the correct answer. The only other thing you would need to know about linear functions is when it has no solution. So obviously we know the solutions where it crosses the x-axis, but when it has no solution, you would just have a horizontal line like this, where 0 would be the slope, and it would just go through the y-intercept. Since it never crosses the x-axis, this means it has no solution. Here's how to solve absolute value questions with Desmos on the SAT. So looking at this practice example, normally with absolute value, you got to set it equal to the positive and negative, whatever's on the other side of the equal sign. But with Desmos, it's incredibly fast. Let me show you. There's a shortcut for the absolute value, or you can hit this A button down here. Let's just go ahead and type in our equation. I can see that it crosses the x-axis in 2 places. These would be our 2 solutions. You can see it crosses. Oh, it's not giving us a dot. So sometimes when it's a complicated equation, Desmos doesn't give us a dot because it itself is having trouble figuring it out. But this is okay because we can clearly see as we zoom in, this is going right through 9, and this other line is going right through -1. So we know our solutions would either be 9 or -1. If this bothers you, the best way to get rid of these vertical lines is just by taking one side of the equation. So in this case, we have 25 on one side, all this other stuff on the other, and moving it to the other side by adding or subtracting it. In this case, this is a positive 25. So really what I want to do is subtract it from the other side. And that's essentially setting all of this equal to 0, where we don't want that. We want these nice crisp lines with the dots. And we can see that the dots are the same at -1 and 9, which would be the answers. And it's asking me the positive solution, so it'd be 9. How to solve square roots with Desmos. I bet you guys can guess it. Just go ahead and plug it in. So let's go type in this equation. Whenever I do square root, I like to type in SQRT because the shorthand keyboard is just way faster. Then I'm going to go type in the rest of this equation. To get it out of the square root, I just press the right arrow and it pushes it over. This is how I navigate through this. And then I can add the 4 equals x plus 3. Then I get my vertical line and I can see it going right through the point 5, which that means the correct answer should be B for this question. You see how fast these are. But if the vertical line still bothers you, just take one side of the equation and move it to the other by subtracting it. So it would make all of this negative. And it's going right through 5 still. So 5 would be the solution for this question. Desmos can even solve complex fraction functions, whatever you want to call them, rational functions. But I think we can both agree that this would be tough to solve by hand. It does not look fun. What we can do is just type it into Desmos. And once again, look at where it crosses the x-axis. That'll be our solutions. Let's go ahead and do that. We have our first function here. I want to close that. And whenever you have something like this and you want to divide it, go ahead and highlight it, click the division. You can either click this or do the shortcut, and it'll just immediately put everything over the denominator. And there we go. We immediately get our solution crossing the x-axis at 2. So we know B is going to be the correct answer for this question. And once again, if this is bothering you, go ahead and pick one side of the equation and move it to the other. I prefer the right side. And since this is kind of complex, I'm just going to put it in brackets and then just go subtract. And then once again, it's crossing 2. How Desmos can solve complex inequalities. These take a bit of explanation. So let's go ahead and try this practice problem and I'll explain as we go. Let's go ahead and type it in because it's like any other function. And you can see how it gives us this shaded region and we have a region that is not shaded. So all of the correct answers that satisfy this inequality will be in the shaded region. In addition to that, we see this dotted line. This means that any value that actually falls onto this line is not a solution to the inequality. And that's because this is less than, not less than or equal to. So whenever you see a dotted line for an inequality on Desmos, know that any point that is on the line cannot be a correct answer. Let me show you what it looks like when it's less than and equal to. You can see it's a bold line, meaning that these are now solutions that do satisfy the inequality. But let's go ahead and try the problem out. And so looking at the points, let's start with A and then work our way up. So typing in A, I can see that -4, let me zoom in here, -4 would be here and -4, 0 would be around here. It's well within the shaded region. So I know A is going to satisfy this equation or inequality. 0, 5, I can see would be slightly outside the shaded region. Therefore, it won't satisfy the inequality. While you do these as well, you can type in points into Desmos. So if I put a parentheses, -4, comma, and then the y value, it'll be a point on Desmos and I can label it. If I wanted to say there, I can see -4, 0 right here in the shaded region. If I wanted to do B, I could do parentheses 0, 5 and label it. And I can see it's outside of the parentheses. Same with 2, 1, or you can eyeball these if you're a little better at looking at graphs, but sometimes it looks a little tiny for me. So I like to look it up. And I can see that all 3 of these except for A do not satisfy the inequality. Therefore, A is the correct answer for this question. How Desmos can help us with quadratics on the SAT. This is fantastic. Some of these are the hardest problems on the SAT and they're solved incredibly fast with Desmos. So you no longer have to factor. Factoring is dead. Desmos is alive. Let me show you how. Take a look at this question. It's asking us what is the x-intercept. So it's asking us a solution. Without Desmos, normally we would have to factor this, break it down, find the x-intercepts. But now I can just take a look at that equation and plug it in and visually find the x-intercepts on the graph. I typed that in correctly, and here we go. right there. I see the negative and the positive intercept, and it's asking us what is an x-intercept of the graph, and clearly A is the correct answer, -12, 0, as the rest of them are not x-intercepts. But in addition to that, if it were asking us the y-intercept, I would see the y-intercept here, and if it asked us the minimum or the maximum, depending on where the parabola was facing upwards or downwards, I'd be able to find it incredibly quickly because it's down here at 9, -441. So once again, Desmos is fantastic for quadratics because it'll tell us the vertex, the x-intercepts, the y-intercepts incredibly fast, and how many solutions there are. But what if they give us a constant in a quadratic? Do not worry, it's easy peasy, I'll show you. Take a look at this question here. Let's go ahead and type it in and just put C in. Just type in C for the constant. And it's gonna ask add slider. You wanna go ahead and click it. For what constants are just numbers that don't change in the equation. You're just putting in 1 as if it were C. And as I move the slider around, it's plugging in different numbers for C. It's presenting the equation, graphing it as if C were 6.1 in this case. So I can see the solutions changing as my C changes as well. In this case, they're asking us the equation has exactly one solution. As I mentioned earlier, solutions are where the graph crosses the x-intercept. In this case, we can see it does it, or the x-axis, excuse me. I can see it does it twice. So right now, there's 2 solutions. And if I move my slider, I'm kind of stuck within these bounds for now. But in this case, they give us answer choices. So let's just go ahead and plug in the answer choices. Right now, at -1.4, there's 2 solutions. Let's start with C and see if we need to go up or down. By plugging in C equals -32. When C is -32, there are 2 solutions. I see when I plug in -50, there is 1 solution. It crosses the x-axis at 1 point. When I type in -68, I see it never touches or crosses the x-axis, meaning there are no solutions when C is -68. This question is asking me when there is 1 solution, therefore the correct answer will be 50 because there is 1 solution. The parabola is touching the x-axis at 1. This next question is much harder, but it is necessary that you guys do it so you can have master slider skills. Let's go ahead and type in the equation like we did last time. But in this case, they do not give us answer choices to plug in for C. Let's go ahead and add the slider. How we solve this is by moving C and making it so it satisfies the equation. In this case, they're asking me C is greater than N if the equation has no solutions. Remember, a solution when dealing with one line is where it crosses the x-axis. When it has no solutions, that means it should not cross the x-axis. What is the least possible value of N? So first off, let's just figure out what the heck is C when there are no solutions, because I can see right now there's 2. Moving the slider, it kind of doesn't do much for me. I need to expand the range of my slider. Here's how you do it. What you want to do is click this 10 or the numbers on both ends of your slider, either one. Then you're going to get something like this. This is where you create the range of your slider. I can make it anything I want. I'm going to put it to -100 and +100 and just click enter. This, you see how it expanded my slider. Now I can really move this graph around. I can see that C is probably going to be a positive number, so I'm going to keep expanding it in the positive direction. I'm just going to put in 200. Moving it even further up, I can see it's inching its way towards no solution and going above the x-axis. So I'm going to expand it one more time to 300, click enter. I can see around 294 is when there begins to be no solution. And then you can click it and start typing in the numbers exactly. So I can see at 290, it's just above it. At 289, look at that. At 289, there's 1 solution. It touches the x-axis. What this tells me is since C has to be greater than N, and there's no solutions. When C is 289, there is 1 solution. So any value of C greater than 289, there will be no solutions. Let's look. At 289.1, there's no solutions. It does not cross the x-axis, but at 289, it does. That means N is 289, because while C is greater than N, there will be no solutions. So 289 is the correct answer for this question. Desmos is amazing for tough system of equation questions on the SAT. It is fantastic to use because otherwise these are hard and time consuming, but with Desmos you can get them incredibly fast and accurately, getting you more points on the math section. Here's how. So systems of equations questions with linear functions on the SAT are going to primarily ask it 3 different ways. They're going to ask it saying, hey, if these lines have no solution, so solutions when dealing with 2 lines is going to be where they intersect. So if there are no solutions, that means they never intersect. And it's going to look like this. They're going to be a pair of parallel lines. How you know this is because they have no solutions. They never touch each other. Parallel lines have the same slope, and they look like this when you plug them into Desmos. Next, they're going to say they intersect at one point, or what are the solutions of this system of equations? That means these lines are going to intersect at a point. It's going to look like this. You can see they intersect. It forms a cross. And the solution to these equations is going to be the x and y values of the point of intersection. Last, they're going to say they have all real numbers or all unlimited solutions, something along those lines. And that's when they're talking about, hey, these are going to be the same exact line. For all points being graphed, it's going to be the exact same line. And when you graph it in Desmos, the lines are just going to overlap. You're going to want to turn the line off and on by clicking the arrow to the left of the equation, and it's going to be directly on top, meaning that this is the same line and that they have infinite solutions. Let's do some examples. Take a look at the question here. We have 2 lines and it's asking us, if there's a solution x and y, what is x times y? So like I said previously, if we have 2 lines and there's a solution, it's going to be where they cross. So let's type this in. They intersect at one point, and if I click it, I see that x is 0.6 and y is 3. They're asking us what is x times y. I'm just going to do 0.6 times 3 and get 1.8 as the correct answer for this question. In this next question, they're saying that this has infinitely many solutions, meaning they're going to be the same line when I graph them. So I'm going to take the equation on the left of the equal sign and plug it into Desmos. I get 2x plus 16. The next equation, I'm going to type in with a as a constant, a times x plus 8. I'm going to add a slider. Looking at both of these lines, I want it so they're going to be the same exact line because they have infinitely many solutions. So I'm just going to move a around until they become the same line. And I can see when a equals 2, both lines are over top of each other, meaning they are the same exact line, and they have infinitely many solutions. So 2 is the correct answer for this question. Take a look at this question here. Go ahead and type it into Desmos. It is saying that these equations have no solution. Now we know that means the lines never intersect each other. So we're just going to go ahead and plug them into Desmos and then click add slider for p so it shows up on our line. And there we go. We can see they intersect at one point when p equals 1. So I'm going to move the slider around, seeing if I can find anything to make it so these lines never intersect. I can see as I inch closer to 6, it doesn't look like they intersect. So I'm going to zoom out and make sure these lines never intersect when p equals 6. And as I keep going, they never intersect. And that tells me that when p equals 6, these lines have no solution, or 6 is going to be the correct answer for this question. So that was systems of equations for linear functions. Here's a system of equations for quadratics. It is the same deal. When there is no solution, the 2 lines do not intersect. When there is one solution, that means they intersect at one point. And when there is 2 solutions, that means they intersect at 2 points. In the xy plane, the equation 2y equals 4.5 intersects the parabola at exactly 1 point. The parabola has an equation -4x squared plus b of x, where b is a positive constant. What is the value of b? Wow, that is a mouthful. Let's plug it in. 2y equals 4.5. We can see that it shows up here. And we have our second equation, -4x squared plus b of x. We're going to add a slider for b. I can see that right now these lines never intersect, therefore there is no solutions. So I'm going to move b until I see that, it said b is a positive constant. So that must be, we're going towards the positive end. And I can see that as b inches 5.8, they don't quite intersect. Let me try out 6. When b equals 6, I can see that they intersect at 1 point, which satisfies this question. So 6 is going to be the correct answer for this question. In addition, if they ever give you a quadratic and they say a line intersects it at 1 point, it has to intersect it at the vertex. If it is a flat line and it intersects it at 1 point, it has to be the vertex of the parabola. Here's how to solve tough translation problems with Desmos on the SAT. What you want to do is define f of x. By typing it in this way, you are telling Desmos that, hey, f of x equals x plus 7. When you do g of x, you're doing the exact same thing. Now, Desmos knows, okay, well, f of x is this, g of x is this. So when I type it in this way, it can plug in 2 into each of these equations, multiplies the outcome from f of x by 4, and then subtracts the outcome from g of x when x equals 2 to give me 22, and it solved it in less than 5 seconds flat. Here's a much harder translation problem that is just as easy to solve using Desmos. You want to go ahead and plug in all the equations as well and define them by typing in f of x equals beforehand. After typing all of these equations in, Desmos went ahead and graphed each one for us, but we're only looking for the x-intercept of y equals h of x. So what I want to do is go ahead and take a look at f of x, click this dot over to the left of the equation to eliminate the graph from the plane. I want to do it with g of x as well. Now I'm left with just h of x. That's the x-intercept. -12 is going to be the correct answer for this question. Here's how to solve system of inequalities with Desmos. This is only kind of different than when you have just one inequality. What you're trying to do here is see which point satisfies both inequalities at the same time. Type in y is less than or equal to 3x plus 1, and you just want to type in the other one and see how we have two graphs in two different shaded regions here. The correct answer will fall in the region that is shaded by both inequalities. Incredibly important that it's both inequalities, not here and not here. We're going to do the same thing as last time. We can eyeball it, or we can plug in the points with Desmos. Do whichever one you prefer. I'm just going to plug in the points to remind you. You can make each point show up on the graph, and you can see where it's put. And I can see that that is outside of any shaded region, so it will not be the correct answer. Let's take a look at B. I see B falls out of both shaded regions. Same with C, so therefore D must be the correct answer. And I can see D falls into the region shaded by both inequalities, therefore it satisfies both inequalities. How to solve equivalent expressions on the SAT using Desmos. You can identify the equivalent expression questions because they always put the word equivalent in them. Which equation is equivalent to this one? Which one is equivalent to that one? And so what this means is which expression is equivalent to this one? Let's go ahead and type in this practice problem into Desmos. It's the same expression, either simplified or numbers distributed. And so what that means is when I graph these, they should create the same graph because they're the same function rewritten. So let's take a look at this practice question. We want to put a plus c normally, and let's add sliders for both. The only thing we need to know is that a and c are going to be positive numbers. So when I do this, I like to pick very easy numbers. You can see that there's no x and y values here, rather a and c. So what we could do is put x and y, or we could just put in values for a and c. In this case, I'm just going to put values in because they're constants. Make a2 and c1. I'm going to pick very easy numbers for this. I can see when I make a2 and c1 that this equation equals 9. Therefore, the correct answer, a, b, c, or d, when I plug it into Desmos, should give me the exact same value. Let's take a look at a. Let's do a plus c. That gives me 3 because remember, I have defined a as 2 and c as 1. I know a is incorrect. A squared plus c squared, that gives me 5. I know b is incorrect. We can do a squared plus 2ac plus c squared, and that gives me 9. Let's double check by putting in d. A squared times c squared gives me 4, so therefore c is going to be the correct answer for this question. Take a look at this next question. The algebra is much more complex, but once again, it's still an equivalent expression, so I know that these two equations are the same equation, just rewritten. So if I were to plug them into Desmos, what I'm going to do is move p around and get it until they're the same exact line graphed. Let me show you. Let's plug in the first equation and plug in the second equation. You can see for this question, we have two graphs. We have our first graph in red, where p equals 1 currently, but we have a slider. And then we have our second graph that's in green. And we want to make it so what value is p when these are the same equation? And if I have two same equations, they should be the same line on the graph or same graph. So I know I'm moving p around. I can see as p gets a little more positive, it starts to touch and become more like that line. But since we have answer choices, I can go ahead and just plug in a, b, c, and d and see what the correct answer is rather than using a slider. So take a look. The first one's -3. I can see that these are clearly not the same line. Let me plug in b, 7. When I plug it in, my line disappears, and that's because whenever you have two same lines, they will be over top of each other. You just want to click the colored circle to the left of your equation to turn it off and on. So I can see that both of these graphs are overlapping, meaning they're the same equation, and B is the correct answer for this question. Here's how to complete regressions with Desmos on the SAT. So what you want to do is whenever you're giving a table, like in the example above, you want to go ahead and just plug in those points. To create a table, you want to go over to this plus mark, click it, and it's going to tell you fx expression, note, and then table here. Go ahead and click that. Then you're going to want to plug in your points. To make a linear line using a regression, you need 2 points. To make a quadratic, you need 3. This makes sense because a linear line, you need 2 points because it's going like that, while a parabola is going to be a smiley face or a frowny face. You kind of need 3 points, one on either end of the vertex. Let's try out this practice problem. So normally when given these points, in order to build a line like they're asking for, this is clearly in y equals mx plus b format. You're gonna have to, do y2 over y1, x2 over x1, then plug it back in to find the y-intercept. It's kind of a pain. Instead, we can plug it into our table here and then hover over this kind of line with some dots around it. And it says add regression. Regression's just fancy for, hey, build me that line. If I click that, I get a linear regression and it's in y equals mx plus b form. So now I can immediately see what the slope is and what the y-intercept is. But if I click down arrow, this caret here, I can make it a quadratic equation. If I wanted to make a cubic regression, so x cubed, and then the other one you might use is an exponential regression. So if I had e to the power of x, or anything to the power of x at that point. So in this case, we want a linear regression, so I'm gonna leave it as that. And the question's asking me, what is a minus b? Well, I can clearly see that a is gonna be the slope. So it's gonna be 64 minus our b value, which is negative 128. 64 minus negative 128 is going to be 192, and so D is going to be the correct answer for this question. Let's do a slightly harder practice problem. Let's go ahead and plug in the points into the table. So you find the table by clicking the plus sign and then hitting table. In this case, they're asking us what is the x-intercept of line H, which is line K shifted down 5 units. Well, what I can do is figure out what line K is really quickly by plugging in these points. I add a regression and it gives me line K like that. I need to tell Desmos that f of x equals line K. And now I just want to make sure that h of x equals f of x, or line K, shifted down 5 units. And it graphs it for me. So instead of doing a bunch of plugging in numbers and algebra, I can just go ahead and plug it in Desmos and see that the y, or the x-intercepts could be negative 2.8333. And I just need to figure out which answer choice is negative 2.8333. They're all negative options, so I'm just going to start with A. Negative 26 over 3 gives me 8.6, negative 9 over 2, negative 11 over 3, negative 3.66, so it must be D, negative 17 over 6, 2.833. Therefore, D is going to be the correct answer for this question. This is how you use regressions on the SAT without a table. You're going to want to plug in that first equation, because remember, regressions, you're just telling Desmos, how do I make this equation equivalent to the next equation? What does the constant have to be? That's what you're telling Desmos what to do. So take a look at this practice equation, and I want you to plug in that first equation. But when you're going to do a regression like this, you have to type in y1 equals 1/3 of x1. You're telling Desmos by putting the 1 next to it, it's saying, hey, for all values of y, for all values of x, this equation is going to be held true. This will make sense as we keep going on. Then you're going to want to square it. And to get the 1 next to the variable, you just type in 1 and immediately pops it down. There's no shift down or anything. You just type in 1 next to the y and next to the x. Desmos knows what you're talking about. And subtract 2. And see, we have this first equation here written. But I had to make sure it's going to be y1, x1. Important, because the next step is to type in the other equation, but it's a little different than what we were doing in the past. So if you wanted to use a table, you could just find points from this graph, plug it into the table, and create your regression. Or you can do it more directly using this method. You're going to want to put in y1, because remember, we've told Desmos, hey, y1 is this. And what you're doing here is saying, hey, bring down this equation. It's going to equal this other one. And instead of an equal sign, you want to type in something called a tilde. That's the shift apostrophe in the top left-hand side of your keyboard or my keyboard. And what you're telling Desmos is saying, this equation is going to equal this equation for all values of x. What would the constants have to be for this to occur? type in the second equation, and it went ahead and it calculated. We looked at all the x and y values on the x and y plane for the first equation, and we told Desmos it needs to look at this new equation, and then we told it it is the same. What does k have to be? So these have the same x and y's on the x and y plane. That's what this tilde is doing, and that's why we used y1 and x1. And it told us that for this to occur, k has to be 2.449. So we know with this practice question, it's not going to be a, it's not going to be b, and it's not going to be c, because it's greater than 2. The square root of 2 is going to be something lower than c. So therefore, it has to be d. Let's check it. The square root of 6 is 2.449. D is the correct answer for this question. This next example is a little bit harder, but just bear with me. We're going to do it the same way we did the last one. I have my first equation typed in, y1. I made sure they're y1s and x1s because I plan on using a regression. So let's type in the next equation. Make sure to use y1 and a tilde. Now that I have my second equation typed in, does that look right to you? Does it look like when I factor all of this and turn it into ax squared plus b of x plus c, that a would be 2 and b and c would just be 1? I don't think so. So sometimes when you don't give Desmos points, it'll not figure it out because you need to show it multiple points on a graph for it to match the graph perfectly. So sometimes when you're getting something and you don't quite agree with what a constant would actually equal, you want to do this. x1 tilde random equals random 5. So x1 equals random 5. You're telling Desmos by doing this, hey, for x of 1, I want you to put in a random 5 number and then make these equations match up. In this case, you see how our a has changed to 0.75, our b has changed to 2.5, and our c has changed to 0.75. I said this earlier, with a linear line, you only need 2 points. With a quadratic, you need more than 3 or more. And this is because you need 1 point on either side of the vertex to show how it's going to go up or down. In this case, if I put in 1, I'm not getting what I'm looking for. If I put in 2, still not getting what I am looking for. And then if I type in 3, this is when I start to get consistent values amongst my constants. So you can see if I put in 100, I still get a is 0.75, b is 2.5, and c is 0.75. But this is a little more complex. We're falling into the realm of it might be easier to do these by hand, but if you're feeling confident with this, you can always have it in your back pocket. There's one more example on regressions dealing with exponential values. Here's how you do it. In this example, we're given 2 points. So we want to go ahead and get our table and plug in our points. And we're given our 2 points here. So normally you would go ahead and click add regression, move down to exponential regression, and it will give it to you. But in this case, they're asking for it in a specific form. We can see that this will be 10 times a number to the power of x. They're asking us what is a to the power of x plus b. This isn't what we're looking for. Don't worry, we're going to combine both of the ideas just taught. We're going to do y1 tilde equals a to the power of x1 and then plus b. So we're saying to Desmos, hey, you see that this function here is going to be equal to this function down here for all y and x values. So can you give me what a and b would be if this were the case? And in this case, a would be 6, b would be 9. The question's asking us, what is a times b? So 6 times 9, it's going to be 54, and that's going to be the correct answer for this question. When you want to solve for mean on the SAT, you just need to type in mean into Desmos, and in the parentheses, type in your data values. Taking a look at the practice question here, you can just type in, and it'll give us the mean, which is 10, really quickly. Here's when it's most useful. Look at this tough mean problem. We want to plug in our first data set. After plugging in the mean for our first data set, we see that it's 74. We have a second data set where we don't quite know what x is, but we know they should have the same mean. Therefore, I can plug in the second data set and just kind of move some numbers around for x until they have the same mean. What I'm going to do is put in a as a constant here so I can have a slider. So I can see when a is 1, my mean is 57. I can keep moving it up until I get the number that I'm looking for. And I can see when my number is 86, they have the same mean, therefore the correct answer is 86. How to solve median questions with Desmos on the SAT. You're gonna wanna go ahead and type in median into Desmos, and in the parentheses, just add your data points. Quickly, it tells me the mean is 3, and that's gonna be the correct answer. For the math SAT, you need to know the circle formula. This is not a replacement for knowing that formula. This is for all of the tough questions where you're not given the formula quite exact. Take a look at this practice example. It's asking me the radius of the circle, but this is clearly not written in normal circle form. We're gonna have to do something called completing the square to solve it, and that's a pretty horrible algebra dense way to solve it. Instead, we can just go ahead and plug this equation into Desmos. So you can see after plugging this in, I get a circle. And what you need to do to find the radius is take a look at the top or the points on the edges of the circle. These are the points where we might not be able to find the radius because that'll make us find the center of the circle and the distance from the center to the edges, but I can find the diameter, which is 2 times the radius. I can do that by finding the distance between these points, between the top 2 points or the points on the sides. I usually just pick the number that's easier. You can see the ones on the sides. These are not nice whole numbers, but the top and bottom ones are. So I'm just going to find the distance between these 2 points. And once I find the distance, that'll be the diameter, and I can divide that by 2. To find the distance between 2 points, just use the distance formula. On Desmos, you can just type it in and then plug in your points. After plugging in my points, I can see that the distance is 10. That's the diameter. So if I want to find the radius, I just take 10 and divide it by 2. And that tells me my radius, which is 5. And that'll be the correct answer for this question. Take a look at this next question. It's asking me where this point lies on a circle. So normally I could plug in 6 and then kind of solve for y, but instead, could I just graph the circle and look at 6 and see which point it is? Yeah. So let's go ahead and plug in the circle. After plugging in the circle, pops up right there. And all I need to do is look at this 6x value, and I can see it touches it at 1 point, which is very convenient at 6, 5. And so 5 is going to be the correct answer for this question. In this last example, we can see that they are asking us what is the center of this circle, but they're not giving us the circle equation. They want us to do a whole bunch of algebra, but we are too smart. We are not going to do that. We're just going to go ahead and plug it into Desmos and take a look. Where was the center of the circle? Where could it be? After plugging in my circle, I see that it's kind of going to be in this second and third quadrant over here. And honestly, looking at the answer choices, I can pretty much guess which one's going to be correct. Wouldn't my center be somewhat around 0.30, 0.29? I can just eyeball it. So very likely it would be answer choice D because it's going to be a negative 29 at a y value of 0. But if I wanted to know for sure, I could take the midpoint. So the point between my 2 edge or my 2 top points, and that would be the center of the circle because it's equidistant from both points. To find the midpoint, you just want to type in midpoint into Desmos and plug in your values. I'm going to use the x values in this case and plug in my first set of negative 58, 0, close the parentheses, and then 0, 0. And it tells me that my midpoint is negative 29, 0. So D will be the correct answer for this question.